Today we're going to be discussing polygons and lines of symmetry. So first thing we need to talk about is a polygon. So a polygon are two-dimensional geometric figures with these characteristics. So they have to be made of only straight lines. Each segment touches only two other segments at the endpoints, and they are closed, which means there's no opening. If you were to fill it, think if you were to fill it up with water, there's no opening for water to escape from. So these shapes are polygons. So as you can see, they're all closed. There's no space for any water to leak out. They all are made of straight lines, and they only touch a line at their endpoints. Now if you look below, it has shapes that are not polygons. So we have we have A, we have B, we have C, and we have D. So let's look at those shapes and let's talk about why they are not polygons. So let's explain. Let's look at A. Well, if we go think about the definition of a polygon, why is A not a polygon? And if we look back, it says they are made of straight line segments. That's the first bullet. Well, A is not made of straight line segments. So not made of straight lines. Segments. Because A is a circle, so A is not a polygon. Now B, it's the same thing. So it's not made of straight line segments. But if you also look, it has an opening here, and it's a little bit harder to see on mine, but that's not closed. Water is going to seep out of that corner right there. So it's also not closed. Okay, for C, again, water is going to escape right here in this opening. So it is not closed. And D's a little bit tricky. So if we look back at the definition of a polygon up at the top, it says they are made of straight line segments. Well, that one's made of straight line segments. If I look at it, everything is straight touching. Exactly, each segment touches only two other segments at the endpoints. That's where we start to run into problems. If I look at this line segment here, it touches not only at the ends, but it also touches in the middle, and that's a big no-no. It can only touch at the end point. So because it's like twisted, that's why it can't be a polygon. So each line segment touches more than two places. You can also put in parentheses it's twisted. If you can see that it's kind of like a twisted shape. Alright, so your job, I want you to circle the shapes that are polygons. So look at the definition of what is a polygon and circle the shapes that are polygons. So you should have had this one, and you should have had this one. This one is not closed, so it can't be a polygon. Alright, so there's your polygons. Now let's talk about a different type of polygon. So this polygon in the first row, those are the triangles, and they have three sides. The next one is a quadrilateral, and they have four sides. The next one is five-sided, and it's called a pentagon. 6 is a hexagon. 7 is a heptagon. 8 is an octagon, like an octopus. 9 is a nonagon. 10 is a decagon, like a decade. Now, polygons with more than 10 sides are not usually given a special name. A polygon with 11 sides is described as an 11agon. A polygon with 12 sides is a 12gon, and so on. Now, we know the names of all these, and even though they're all looking very different, they all, like if we look at the triangle, there's 3 different shapes of the triangle, but they're all considered triangles because they all have 3 sides. Same thing with the quadrilateral. Even though they all look different, they're all quadrilaterals because they all have 4 sides. But there's this fancy word called a regular polygon. And they are polygons with sides that are all the same length and angles that have all the same measure. So all their angles are exactly the same and all their side lengths are exactly the same. So it says, using your eyes, circle or highlight the regular polygons in each of the rows above. So they have to have the same side length and the same angle measures. So let's look at the triangle. Which triangle has all equal sides and all equal angles? Well, that would be this triangle right here. The one in the middle, the hypotenuse, or the longer angle of it, the longer side, is longest. It's longer. And the angles are not all the same measurement. This one up top right here is too big. And then the same thing with this triangle here. This is a right angle, and these angles are not exactly the same. So neither of those are right, are regular. Let's look at the quadrilateral. Which one is the regular quadrilateral? Well, it has to have all same sides, all same angles. It's the square. Pentagon. All same sides, all same angles. It should be this one. So I want you to take a pause. I want you to try 6 through 10. See if you can figure out which one is the regular one. So which one is all the same side length and all the same angle measurement. And you'll start to see a pattern in them. So this one is the regular hexagon. This one is the regular heptagon. This one is the regular octagon. This one is the regular nonagon. And this is the regular decagon. So you see they all kind of start making circles because as they get more sides, they have to have the same angles, so they get closer and closer and closer and closer and closer to the shape of a circle. So those are your regular shapes. And a lot of times we see when we're told there's a hexagon, we're told the shape looks like a regular hexagon. All right, so now let's talk about lines of symmetry. So you may have heard of lines of symmetry before, and I wouldn't be surprised if you learned it in your elementary school classroom. A line of symmetry is an imaginary line where you could fold the image and they have both exactly the same on both sides, so they match exactly. So when the folded part sits perfectly on top of all the edges matching, the folded line is a line of symmetry. So here I have folded a rectangle one way and it didn't work. So if you fold a rectangle on a diagonal, because the sides don't lay over each other perfectly, this is not a line of symmetry. But when you fold it a different way, so when you fold it down the middle, both pieces will lay on top of each other. So this is a line of symmetry. They have to lay on top of each other perfectly. They can't be twisted. So is the dashed line a line of symmetry? So if we look at the first one, if I cut it here, it won't perfectly lay on top of each other, so this one is a no. If I look at this one, it cuts it straight in the middle. The top is the same as the bottom, so this one is a yes. Go ahead, pause, try to do the last two. So this one is a no, because the squigglies on top are not the matching for the bottom. And this one, they'll both be exactly the same, so this one is a yes. So for this one, it says draw all the lines of symmetry for each shape and then write how many there are. So if I look at this triangle, I want to try to figure out all the different ways that I could fold it and be exactly the same. So I could cut it here and it'd be the same. I could cut it here and it would still be exactly the same. Or I could cut it here and it would still be exactly the same. So there's technically 3 lines of symmetry. You try the next one. How many lines of symmetry do you think there are? In this example, there's actually no lines of symmetry. So there's no way I could easily cut this shape and it be divided. So there's none in this one. Try this square. How many lines of symmetry? So a lot of you probably saw this one. So there's 1, and you probably saw this one. There's 2. The diagonals you might have forgotten about, so there's 3. But then I also have the other diagonal. So that's 4. So a square has 4 lines of symmetry. Okay, so let's take it a step further. A regular polygon has all sides equal and all equal angles, but check out what happens with the lines of symmetry when you have a regular polygon. So this is the first one's called an equilateral triangle. And an equilateral triangle, it's a regular triangle, but we just call it equilateral. It has 3 sides that are perfect, that are equal. We have 3 angles that are perfect and are equal. Now, watch what happens when we kind of did this one on the other page. Here's a line of symmetry. Here would be a line of symmetry. And here would be a line of symmetry. So I have an equilateral triangle. It has 3 sides that are perfect. It has 3 angles that are perfect. So I have 3 lines of symmetry. Now, we did the square on the other page too. A square is a regular quadrilateral. So it would fold there. It would fold here. We could fold here. We could also fold there. So that gives us 4 perfect angles, 4 perfect sides, 4 lines of symmetry. Isn't that interesting? A shape with 3 congruent sides, congruent angles, had 3 lines of symmetry, and a square with 4 congruent sides, 4 congruent angles, also had 4 lines of symmetry. Interesting. So if we have a regular pentagon, that means a pentagon that has all congruent sides, all congruent angles. 5 congruent sides, 5 congruent angles. Let's check out the lines of symmetry. So there would be 1. There's 2. There's 3. There's 4. And there's 5. There are 5 lines of symmetry in a regular pentagon that has 5 congruent sides and 5 congruent angles. I bet you could figure out the hexagon and the heptagon and the octagon all by yourself without even having to draw them. A hexagon has 6 congruent sides, 6 congruent angles, as long as it's a regular hexagon. And it's going to have 6 lines of symmetry. There's the first one, the second one, the third one, the fourth one, the fifth one, and the 6th one. So it has 6 lines of symmetry. A regular heptagon has 7 congruent sides, 7 congruent angles, and 7 lines of symmetry. There's 1. There's 2. It's like each point goes to the flat end. There's 3. There's 4. There's 5. There's 6. And there's 7. So if you want to cut it, this one's kind of hard to see. Whoa, that was bad. That's what it would look like. And then an octagon's going to have 8. So, let's see. 1, 2, 3, 4. So I can connect all the points, and then I can also connect all the empty spaces. 5, 6, 7, 8. Okay. And then just to try it, if the pattern continues, a regular polygon with 9 sides will have 9 lines of symmetry, and a regular polygon with 10 sides will have 10 lines of symmetry. Alright, so last page, this is where I want you to kind of do some practice. We'll do the first one together. So this shape here, is it a polygon? Well, no, it's not a polygon because it's not closed. So, if yes, name it. Well, it's not a polygon, so it has no name, so I don't need to put anything here. Is it regular? Does it have all congruent sides and all congruent angles? Nope. How many lines of symmetry? Well, it's not closed, so none. I can't even draw a line of symmetry. We'll do one more together. If I look at this shape here, is it a polygon? Yes, it is closed. There's no twisting. And let's name it. Well, how many sides does it have? 1, 2, 3, 4, 5, 6. It's 6. So it's a hexagon. If you need to look back at those, do. You have to remember the names. Is it regular? Does it have all congruent sides and all congruent angles? Well, it appears to. So I'm going to say yes. And then how many lines of symmetry? Well, if it's regular, remember from that previous page, if it's regular, that means it has all congruent sides, all congruent angles, and the exact same lines of symmetry. So a hexagon has 6, and it's regular, so it has 6 lines of symmetry. So what I want for you to do is I want you to finish the rest of the shapes on this page. If you're stuck, go see your teacher, and when you're ready, you can unpause the video and check your work. And here are your answers. So the first one was a quadrilateral. It was a polygon. No, it was not regular, and it has 1 line of symmetry down here. The next one's a hexagon. No, it's not regular, and it has 0 lines of symmetry. The one after that is the pentagon. It is regular, so remember regular polygons, the sides and the angles match the lines of symmetry. The next one is also, the last two are also both hexagons. No, they are not regular, and the last one has a line of symmetry right through there. So make sure if you have teachers or questions, you go see your teacher. Obviously, you have teachers.